Okay, so for this video, we'll be looking at how to find the order of the reaction for certain substances, certain certain molecules in a equation, and the overall reaction for the equation as well, or the overall order of the reaction for the equation, right? So yeah, and to be specific, we'll be doing some past paper questions. I'll be looking at For this video, I'll be looking at question 1, part A, and doing question I, right? Yeah, I'm going to do question with him again for part A. Question 1, I'm going to be doing question 2 in the next video. All right. So the quickest way how to find the order of the reaction, right? Wait, before going to that, I'm just going to read this. The rate of the following reaction in aqueous solution is monitored by measuring the rate of formation of iodine, right? Data obtained are listed in the table below. So you get the date, get the data in the table below right there. So there you have the balance equation. All right, so the first question is, determine the order of reaction with respect to sulfur, S2O8, with respect to iodine, I, and the overall experiment, order of reaction for the overall experiment. So the quickest way how to find out the order of the reaction for like sulfur, for example, is that anything like when you multiply, okay, for example, when I use the first experiment, when you multiply anything that you multiply to get the value for the second experiment here for sulfur at the bottom part, there's 0.076, right? If you multiply 0.0, anything that you multiply 0.038 by to get the 0.076, if you can do that for the initial rate of reaction for experiment 1 and 2, that means that it's a first order reaction, right? To find the second order reaction is that all you would need to do is that you do the same thing, but basically what you multiply the moles per liter by, when it comes to the initial rate now, you would times anything that you multiply it by, you would have a times it by 2, right? You would have it to the power of 2. Yeah, you would have it, you times it by, have it to the power 2, yeah, right. Okay, so that's the shortest. Okay, and for to find out if it's a zero order reaction, this is basically simple. Like even if the value change for the substance, but the initial rate does not change, that means that is a zero order reaction. So that is the short. So that is the short way how to do it. But when it comes to questions like this, it would be you'll not only be marked based on the answer that you get, but you would also be marked based on the what you call that now, based on the working out as well, right? Working out of the equation, right? Like how you get the answer and stuff like that. So yeah, so for the long way now, we're going to do that. All right, let me just all right, so for the long way now, what you would do is, first of all, you would write the balance equation. But for time purposes, I'm not going to write the balance equation, but you'd write the balance equation, which would be sulfur plus iodine gives you the reactant and stuff like that. And below that balance equation, now you'd write the values, right? Yeah, so you write you choose, oh, first, I forgot one thing. Before you do this now, how you find this out there? How you know what experiments to use is that, okay, we're looking for the order of reaction for sulfur, right? So you choose two experiment that has two different values for sulfur, right? Two experiment that has two different values for sulfur, but the same value for the same moles per liter for iodine, right? And those two experiments will be experiment 1 and experiment 2, right there. Different value for sulfur, same value for iodine. Yeah. And the reason why we need to choose something that has the same value for iodine is because we want to get iodine out of the equation. Right? So we need to leave sulfur in the, so that's why, because when you have the two same values, you're going to see after. Let me see, is it supposed to be, check back on this. Yeah, so okay, so it's 6, right? So it's 6, right? So I'm putting the first with them again. I'm putting the second experiment first to get the larger number on top. I don't think I need to do this, but I prefer doing it like just in case. Yeah. All right. So that's the second experiment there. That's a larger number. Multiply with okay. This is for 0, 0.038. Is it 8? Yes, it's 8. All right. Open bracket, close bracket, and you would put a x here. Reason why you would put a x there is that it is a placeholder for the order of the reaction, right? Because we don't know the order of the reaction as yet, we put a x there. We don't know, yeah. And this will come in play. This will come in play in the later down in the equation, and you would see how it comes in play. Okay. Iodine has the same, what do you call that? Same that for dent equals to 2 and 8. Okay, I'll make a mistake. Okay, I can just exponential of -5, right, over this, and just ensure that you have the weight again. If you're going to put experiment 2 on top, ensure that it's all of the things for like sulfur, for iodine, and the rate of reaction is on top as well. Ensure that you do that. Right. Okay, so that's right, and then you would sort of divide that by that is 1, so you can just cross it out. This will not come in play as well, cross it out. So you'd only believe with this and this. So this is why we choose something, because we were looking for the order of the reaction for sulfur. This is why we choose something that has choose the experiment that has the same order of reaction, same values, same moles per liter for iodine, so that you can X it out. Because that by itself is 1, so yeah, that wouldn't come in play, right? Because you could show it like if I put the 1 here, the answer for this multiplied by 1 would be the same thing. So yeah, right. So the answer for this now would be 2, right? Maybe 2 here. Okay, then you have this 2 here equals 2 over this side. Okay, right? And remember now, this is the order of the reaction here, and this is what we're trying to find, x, right? So now how you would get, so what we need to do is get x by itself. And how we would get x by itself is that we would basically multiply, not multiply, like carry it over. When you carry it over, it would be carry over the 2 like that. It would be log, no, log. Right? It would be log 2 over log 2, right? And you would get, and that would give you that right there, right? You would get 1. So yeah, that's basically it. Yeah, so the order of the reaction would be a sort of first order reaction, right? The order of reaction is with, yeah, the order of reaction is first order reaction 1, yeah. So yeah, right, so we're going to do for iodine now. Let me just solve that. Okay, so look at the values for iodine. So for iodine, so as again, we did this basically the same thing that we did for sulfur, right? But we're doing it for iodine now, where we choose two different values that we choose value that has different things for iodine, right? But has the same value for sulfur, has same moles per liter for sulfur, right? Right, and those two experiments, right? Choose the two experiments, same different for different values, moles per liter for iodine, same moles per liter for sulfur, and that would be experiment 2 and experiment 3, right? As you can see here, same, different here, right? And we'll basically do the same thing back again, where yeah, again, you would put the equation, the balance equation on top right here, but for time purposes, I'm not going to do that. Yeah, right, so okay. All right, so yeah, we'll just do this 0.076 over 0.076. I should write this better. Yeah, but you know that that's a 0.076, and this is the order of reaction here, multiplied by, oh, and I'm going to use the experiment that has the largest value for iodine on top. So yeah, and as I said, if you're going to put with again the value for iodine on top, you would need on top the larger value for iodine on top and the smaller value for iodine on the bottom. You'd need to put anywhere the larger value is, what experiment the larger value is, you need to put all the experiment on top, right? So yeah, that's it. And that would be experiment 2. Experiment 2 had this value, right? So yeah, that's what we're going to put, this value. So that means that experiment 2, all of experiment 2 would be on top right there. Right. Oh, snap. Sorry for my bad writing. It's supposed to be a 6. Oh, sir. Okay. So yeah, then you have the y right there equals to, what is it equal to 2? 5 equals to 5.6. 5.6 exponential to the power of 5, power of -5 to be specific, and then you have 2.8 exponential to the power of -5. Okay, all right, so I have experiment 2 on the top here, experiment 3 on the top here, experiment 2 on the bottom part. Order of the reaction here, order of the reaction here, we don't know the order of the reaction, so we just leave that out, right? And we right here know that this would give you 1, so you can just cross it out. You can just cross this out as well, right? And you would leave with this. This would give you 2, right? And you have y right here. This would equal to 2 as well, right? Equal to 2 as well. Then y equals 2. Like we're going to carry the 2 over, and when you carry it over, it would be a log. So you have the log right there, right? And so y equals to log 2 over log 2. Log 2. All right. And now you know that that would be equal to, you know what, let me just write it over this side. That would be equal to 1 right here. All right, so that's how you find the order of the reaction. So that's how you find the order of reaction for the, what you call that now, for the different molecules within the experiment, right? So yeah, yeah, and yeah, that's about it right here. All right. So how? Okay, let me just pick up everything. All right. So now we're at the last part of I, where they said to find the what they call that now, the overall order of reaction, right? So we're trying to find the overall order of the reaction for the experiment, right? And for this one now, it's pretty easy. It's pretty easy. What you would need to do now is to just add the order of the reaction for sulfur and add the order of reaction for iodine that you got, right? So just add them together and then you get the overall order of the reaction, right? So let's just do that. So we know that the order of the reaction for sulfur was 1, order plus the order of reaction for iodine was 1, right? 1 plus 1 gives you 2. And there, that's the overall order of the reaction for the, what you call it now? Yeah, that's the overall order of reaction. So yeah, that's it. I'm going to do the next video. I'm going to do the, what you call it now? So the II in the next video. But to just ensure that, just for summary, right? How you define the simplest way how to find the order of the reaction. Like firstly, you would need to write a balance equation. You already gave us the balance equation, so we don't need to worry about that. The secondly, no, right? Simplest way to find the order of the reaction is that anything that you multiply, like choose 2 experiments with 2 different values. If you multiply, no, well, choose 2 experiments, right? And if you what you multiply the one of the experiment by, if you get the same value, if you get the answer that you get, if it's the same as that, same as the next experiment, right? And that same thing that you multiply by, for example, like sulfur, if I multiply 0.038 by 2, you would get the value, the value for sulfur in the second experiment, which is 0.076, right? And if you can multiply it by the initial rate of reaction, right? Multiply 1.4 exponential to the power of -5 by 2, you would get 2.8 exponential to the power of -5, right? That means it's a first order reaction, right? Yeah, and to find out if it's a second order reaction now, all you would need to do is to just, anything that you multiply the reactant by, anything that you multiply the what you multiply the reactant by to get the value for the next experiment, or the next experiment for the same reactant. If you can do that for the initial rate of reaction for the 2 same experiments, right? But it's just with them again to the power of 2, then yeah, it's a second order reaction, meaning that by, for example, sulfur multiply 0.038 by 2, you will get that. And right, if it was a second order reaction now, if you multiply 1.4 exponential to the power of -5 by 2 to the power of 2, and the answer that you would get for that would be the initial rate for the second experiment, then that means it's a second order reaction, right? For zero order reaction, it doesn't matter what the value for, with him again, this 2 values for sulfur are, the initial rate of reaction would be the same. That's how you know that it's a second order reaction. That's how you know that it's a zero order reaction, right? Yeah, so that's it.